Hello, hello. Welcome to another episode of Designing in Onshape. This is a series of live streams on this channel where I sort of go through for now anyway, redesign of a robot that my students actually built as a capstone project, a minor redesign to sort of make the thing a little more robust for the certain application that we use it for, which is career fairs, college fairs, that kind of thing, where turns out visitors can be kind of rough on the thing. So part of the idea of this series is that I sort of walk through my thought process as a mechanical designer with some experience, the thought process I go through with how to sort of get things to fit together and, you know, make them actually buildable and workable. So let's dive right in to our design, and this is sort of where we left it off. I was just playing with some other tabs because on today's docket is getting our sensors put in this guy. So we sort of stopped last week. We got the main Arduino board in there. That took a lot longer than I was kind of expecting. You know, we got also blocked in. These will be little LED strips. Adafruit calls them neopixels. And the idea behind those are an addition. And the idea behind those is just to sort of give it some bling. Like I said, these things are mostly intended to draw attention and draw interest from students at college fairs and career fairs, and sort of giving them, you know, giving them a little bit of the shiny is kind of a good thing. So I think we will dive right in and start getting some sensors in. Now, I had, when I sort of brought the screen up in the first place, I was looking at the bill of materials because some of the sensors I need are in here. I think first, though, so things like Let's see, things like this here, the long distance IR proximity sensor. So that's a sensor that goes underneath. And on the existing robot, grab one of the originals here. On the existing robot, underneath are two of those sensors. And the idea is those are light sensors that we can use to sort of follow a line, do the whole line following thing. And then there's also, oh, my battery, I must be shorting something out as I squeeze. I see lights coming on, even though the power's off. I'm going to go ahead and unplug that when I get a chance here off camera. But the other thing under there is an RFID sensor. And the idea behind including that was to sort of supplement the line following thing. So there's a lot of robots in industry, material handling robots, warehouse robots, that kind of thing, that sort of use RFID tags on the floor, especially at intersections, so that the robot knows where it is in the factory and where it needs to go. So that's sort of the idea behind that guy. I also have an idea, like when this thing is finished, also have an idea to use the Bluetooth that's built into this guy, along with an RFID and Bluetooth beacon, to see if maybe I can just get this thing to follow the beacon, which would be kind of cool. But got to have a finished robot before we start to think about actually programming the thing. So with that, what I started to say, all of those things go underneath, but I have also made the decision to add 3 sensors to this guy that don't point straight down, but they sort of point forward. In fact, the plan is to orient them the same as sort of these connectors. These connectors on the top are for, as I keep going, I don't clean up my desk. I'll just use this guy. I don't clean up my desk, so I end up with a pile of parts. The ultrasonic sensors ultimately will get plugged in, though, and again, the solid model there I sort of screwed up when I did the PCB design and used male pins instead of female sockets, which doesn't really matter. They have the same footprint. Like, these get soldered anyway. So from a mechanical design standpoint, they don't matter. Like, at some point, I probably want to trade them out so that I can get everything in here and maybe do a rendering, which I think would look kind of cool. Of course, to do that right, I also have to get the connectors for these cables and the wires and stuff in, the few wires that will be in here, which is, frankly, kind of a pain. Might be worth it to someone watching this in the future, hi from the past, by the way, to show how to do that, how to do wires in sort of a quick and dirty way. Like, it's not really mechanical design, though. That's strictly, to get the wires in here, is strictly for appearances. So we'll get there when we get there. But first off, the sensors sort of facing forward, and I also have up in my tabs, I have Adafruit open already, because honestly, I don't remember the sensors I bought for those. I went with IR, and I think I went with time of flight. So I'm just going to hit this, and I don't remember. And the bad part is they're already sitting on my desk back on campus. And yeah, I don't really remember which one I bought. I don't think I paid $15 for them. That would have been kind of weird of me. But that actually does look correct. So the difference between this and what's already on there is the sensors that are pointed straight down underneath for the line following are designed as sort of light sensors. Now, technically, time of flight's the same thing. It's shooting out a laser beam, measuring the time to return, and you can see in sort of the GIF that's playing, it measures a distance that way. So it's another way to do the same thing the ultrasonic sensors are doing. And honestly, I'm just adding them because it gives us more options, right? I've got the room, I've got the I/O. I might as well. There's like no reason not to. Besides, again, I didn't think I spent $15 a piece on them. But the reason I wanted to see this is because I also have the Adafruit CAD library open. I found this a while ago on GitHub. Most of the boards they make have solid models in here already, which is very nice for what we're doing. And I gotta say, I'm thinking, despite not knowing the exact part number, I gotta believe they have the same basic layout, because really the only difference between all these ones I'm seeing is, effective distance. and I really don't remember which one I grabbed. So, I mean, I could look it up. Let's start. I could look it up in my like order history. I don't really want to dig through my email though to find that because it goes through POs, through the college, all that good stuff. So let's just pick one. I guess this is one of those command decision moments. I mean, we pick one and hope because as I look at these, I'm pretty positive it's going to be one of these. Actually, now that I see this VL whatever X, I think I labeled the board. Look at me. This is where screen printing comes in handy. So it's intended to plug in here. I actually have the boards also at my desk on campus, but I put the screen printing on there. So 53L0X. 53L0X is this guy. And that is product ID 3317. So I'm going to hop over to their CAD library and see 3317. We don't have one. Well, we got a 3316, and does that match one of the other guys? Not one of those. So 3967 is a thing. 3967 is not in the... Well, let's scroll all the way down. I mean, maybe something got out of whack. Just to make sure. Yeah, I don't see it. VL, I wonder if it might be under the VL something. Maybe, I don't know. Let's just make sure this is one of those instances. Just double check, make sure nothing's getting lost here in the alphabetical, but it's kind of easy to be alphabetical when everything's named numerically, right? So everything should be in numerical order, I would guess. I don't see anybody hidden. Panel mount LED. So, all right, what's one of the other ones? 3317 doesn't exist. 3967 does not exist. 5425. 5425. 54. Nope. Man. Striking out all over the place. Let's try that top one. Did I look for that one? 5396. 5396. 53. Whoop. 5396. Look at you. Let's bring you in step file. Nothing to lose at this point. Even if it's wrong, I will verify before I get too far along. But we got it downloaded. Let's get that bad boy imported in here. Import this, open. I've been clicking the composite part thing. I'm not going to do it for this one. Like I said, sometimes it helps. I think it helped with the LEDs. This. And what I want to do to sort of verify, because realistically, all that matters here is the location of where these will be header pins. So just like we did on the top, let's look at the, first I'm going to move the chassis because that's really the main part we're working on. All of these little cutouts are designed to allow clearance for the solder pins on the backside of this PCB once we get it all assembled. It's not flush. We need a place to put those pins. So that's what those cutouts are for. And that's really... the screw holes and these holes are really all that matters. We need to make sure we recess a spot for these whenever we get it where it needs to go. And we need the right mounting hole pattern and preferably size, right? Just to make sure the thing hangs on. But so I'm going to head back to Adafruit. I want to look at, which one was it that I actually downloaded? The 5396. So we're going to go in there. I'm pretty sure that's not the one I bought, given that that's not what I labeled my... given that that's not what I labeled the board. But I want to see, do we have... that's for the sensor. Dimensions. Do we have a drawing? Is there a drawing? My one hang-up maybe about Adafruit is the not good... so there we go. Basically combines the short range and a sensor body with increased range. So technical details doesn't actually have a drawing in it. What about this guy? What if we go to the primary guide here? Sometimes in these primary guides, they have drawings, and really all I need is something. Let's head up to, there's a table of contents usually somewhere. Let's go to downloads, data sheet, GitHub. This is, I think, where I stumbled on that GitHub deposit. All right, so that's just the data sheet for the actual sensor. There we go. This is really all I need, right? This is really all I need. So that's telling me that those holes should be 0.8 apart. If we switch back to our model, measure, parallel axis 0.8. And just for verification, go vertical as well. Not min distance, because I clicked wrong. I don't want min, I want center, half an inch. Half an inch on center, get the right tab, half an inch on center. So, probably not the same part number, the same PCB, though it's based on the same PCB. So they changed some components apparently to get a different range, which is fine. It's good for us. So, first thing I want to do is, I know when I bring that in, it's going to give me a hassle as far as mating things, right? If I mount this PCB, we've seen it before. So I need to first fix. I like to fix the board. It doesn't really matter what we fix. And then we're going to select the board and everything else. So shift all of it and group them together. That way, once we accept this group, now when I bring this assembly in, nothing will move, right? And that's carried over to this. And I'm actually going to use this assembly. These are effectively the same assemblies, and I don't know why I get two when I bring parts in that way. But I'm going to use this one because then in my bill of materials, it'll actually show up with this name, which again, even though not quite the same part number, it gets me kind of close. And I like it that it'll be in here, it'll be in the bill of materials. So I'm going to go ahead and bring one of those in. Just one for now. And we want assemblies and... did I not hide the rest of those? I guess not. We're going to bring in that guy. Alright, I'm going to put it up here. Now again, these need to be mounted, and I'm going to mount them underneath so we don't have anything, well, one, we can't have anything hanging up. So again, if we look at how these sort of ultrasonics mount to the front there, I can't have anything sort of up. Otherwise, it'll interfere with the ultrasonic. So kind of my only option is to take these and hang them down. And the cool part is we got the motors and stuff hanging down here, so it's not really adding any height to our design here, which I like. Keep things nice and slim. So what I need to do first is I need to get a platform, some sort of backing in here to get this guy mounted. And I'm noodling, the thought process running through my head right now is how best to do that. Like, I need to get that guy in there underneath here in a way that lets me still mount everybody else. And since I know I need to have one angled, like the front one's kind of easy, right? I can always stick a rectangle down here and get the front one. But what I'm thinking right now is I kind of need to make sure I don't encroach on this screw hole, because if I just put, let's go ahead and edit the chassis, and I'll show you what I'm sort of thinking about. If I just sketch on this surface, and if I just sort of put the platform, let's create an aligned rectangle. If I were to just extrude like this way, I'm going to guess at what a 45 is. Like, I need that much material to mount the board. I'm going to be hanging way out, and I'm going to be in that screw hole. And effectively, the screw hole is going to be in the way, right? The screw hole, like, in reality is not in the way because the screw hole is kind of inviolate. I need that to be left alone. That's sort of mounting my main PCB. So that's sort of inviolate. I can't touch it. So, I mean, I'm kind of curious. I'm wondering if I could go right off of this surface, sort of bring it down, bring whatever mounting feature I create down, and then use these screw holes to sort of hold it in position, be the material that holds those mounting things, mounting areas in place. That actually does not sound like a completely terrible idea. Let's do it. Why not? But what I'm curious about, what's the height here? Parallel distance, 0.641. I mean, I got plenty of room. If we look at the assembly, I got plenty of room between the underside. This is the underside of the motor mount and the wheel. I got plenty of room to come down even further, but I want to try to stay, I want as much, for no good reason, by the way, I want as much ground clearance as possible. No good reason. But I want ground clearance. Now, that may change. I will be honest, I have not looked at the specifications of that of that RFID sensor. So I may have to get it way down low anyway, but for now, I'm going to work with the idea that I want to maintain as much ground clearance as possible, and I basically have 5/8 of an inch to play with. Is that enough? Now is going to be the question. So, what is the total width of this thing? If I mount it, obviously narrow side, sort of vertical, 0.7. So I'm not going to have enough, but that's still okay. It'll be hanging down a little bit if I use this surface, this plane, as the basis for where those mount. I kind of do like that. I kind of do. Now I'm trying to think about the best way to sort of, like, I want to use these as the plastic, the material that holds the mounts in place. Aesthetically, I'm jumping ahead to looks. I'm not going to like the look of just two cylinders hanging out down there. So I'm probably going to add some material in between, even though that increases our weight. Probably going to add some material in between just for looks, and make this, rather than two independent cylinders, make it, I don't know, a rectangle, a bean shape, or a slot shape with rounded ends. Something like that is where my mind is going right now. So let's go ahead and do that. Well, I can always do this. I'm going to go ahead and, well, I got to be on the chassis first. And we need a bottom view. I'm going to go ahead and sketch in whereabouts those features need to be. So I'm going to create a sketch on this plane, even though I'm going to add material before I actually get around to really creating those mounts. But for now, I just want to sort of sketch in where they need to be. So we're going to go here. I mean, and at this point, I'm guessing. This is just a guess, but I'm basically creating. I got one pointed forward right and two pointed out to the side at 45-degree angles. So we're going to start to constrain the sketch. Those guys will be perpendicular. These guys will be perpendicular. Nothing up there will be, but these will be perpendicular, as will these, and perpendicular. And things will move around. That happens sometimes when you're dealing with this stuff. Except, why won't you let me? Is this got to move in? Will you let me swing it then? There we go. And with it being underneath, we can kind of leave it set back. I like that. That means this sort of leading edge of the chassis will act more as a bumper. Like, people won't be running. Like, if they run into a wall, they won't be, smacking into my sensors. So we need 45 degrees. Why? Just because that's what the originals were, and I don't see a reason to change it. So we need 45 degrees between here and here. That'll bring that in line. 45 degrees between here and here. All right. Now, I'm also going to go back to the assembly and grab sort of the, and actually I don't need the assembly, I just need this. So overall, I'm going to go bigger than the board because we also need to get the screw bosses in. We can't forget that. Or the screw bosses, the threaded inserts. We can't forget that we need enough material for that. So I'm going to go longer, but we're an inch long. We're an inch long. We need an inch for the board. Not Alt-Tab. That's a workflow thing, SolidWorks. I'm used to Alt-Tabbing. And I want chassis, not the assembly. Go back to the bottom view, make sure we're good and square. So we need an inch. inch and a half should be plenty. Again, that's just a guess. There's not really a thought process behind it. Just an inch and a half feels safe, right? We need an inch and a half to mount the board and leave us enough material. So I'm also going to set, actually I'm not, I'm going to set these as equal. I was going to define an inch and a half at each, but I like equal better because I know they're all the same part number. I'm also going to set this equal. I haven't set the thickness yet, but I'm going to set that equal. Equal. And I need a construction line. So I can still move this, right? I can get way thick, way thin, right? I don't want that. I want this to be uniform. I don't know, like I say, I don't know exactly how it's going to end up looking quite yet, but I want it uniform. So I need a construction line to make that happen. And I'm going to go center to center, basically. Make this a construction line. Construction, there it is. Construction, now I can set that construction line equal to the two ends. Now no matter what I decide, I haven't done the mathy yet, equal. So now we're equally spaced. No matter what I set these, can I actually drag? Once I set a thickness, it'll change everything. But we know we got an inch and a half at least. We know we've got enough material for screws. So now it's, well, also I want to make this, can I make that construction line, since I know that's the middle, make it coincident with the middle. There, now we're locked in the middle. We can't go side to side. Now, placement of this guy. Now, obviously, I'm not actually going to reach. If I wanted to reach those screw bosses like I originally said, I'd be way up here, right? And then my sensors would be hanging out in space, which I don't like. What do we want to do? If I do this sort of this way, about where I've got it, I can build out from here. Rather than just sensor mounts for those 3 time-of-flight sensors, I can make this an entire sort of surface here for the purpose of sensors. Like I can squeeze the 2 light sensors for line following in this gap. I can also squeeze the RFID on it. So why wouldn't I do that? Like, why wouldn't I do that? Let's just focus on this for now. I can always add material to do that, make a whole sensor platform, because right now I want to make sure that these are in the right spot for those sensors that I'm on right at this moment. And that's all I'm thinking about. So, I mean, where do we like? I kind of like it where it is, just like for looks. It's behind those screw bosses. I'm gonna have to come up with a way to get all that attached, because right now I'm floating out in space. But I'm gonna have to come up with a way to get that all attached. But for now I can at least lay it out. And come up with a plan. The other option is, I mean, since I know I'm not going to hit those screw bosses now, I can always accept the sketch, and I can edit. Well, maybe I didn't need to accept it. I can change the sketch plane to this, and it won't affect anything. So now it's on that, and when I extrude, it's sort of automatically connected. I'll just have to make sure now when I extrude, I need to basically, this is dead material between the bottom of the chassis and the bottom of the screw boss is dead material. So I need to come out that much before I even consider the height of the sensors. That 0.7, I think it was. So that's a thing that I need to remember now that I've done it this way. But that works. I am not unhappy with that, and I think I like that plan of getting those others. So I am going to change my mind, and I am going to get those other sensors in there. And those sensors were, the ones that exist, the light sensors, are 6064. So without even going to their website, I'm just going to jump in here and see if I can get a 6064. Yes, I like it. The step file, download that and get it in to my assembly. So here, import 6064. import again. I'm not going to worry about the composite because I'm wondering if I can tuck those right in here and do this as one platform. And then for the RFID, I can just make the battery compartment taller, and really just tall enough for some threaded inserts. Like, we've already got material here. It's about as thin as you can possibly get for the battery. But if we just add on to this surface and make it taller, add plastic, I mean, for the purpose of that, for threaded inserts for that RFID board, that wouldn't be a terrible idea. I don't think. I mean, I don't know. It's a guess, but it doesn't sound horrible. So did that actually bring that in? It did. So this is the other board. Tell me it's got the same footprint. 0.75. Yep, same footprint. So I think to lay it out, I'm just going to put squares in that sketch for now, or rectangles. 0.7 by 1. Is that what it is? 0.7 by 1. And do that. And what does that look like if I go back to the chassis in the bottom view and just drop I want it straight this time. Here and here. And if I just go equal, whoops, no control, just click, folks, just click. That's one of the workflow things, Onshape versus SolidWorks. Just click, no control, click. So equal, so now if I do, I also want coincident, I want them in line. Coincident, and make this a 1, and make this a 0.7. Now I'm going to probably delete these. Right now they're just here to see where I can fit things. And I need to be very careful. I want to spread them out. I need to be very careful right now that they don't get too close together. They are electrically going to be daisy chained together. These connectors, there's an in and an out. You can daisy chain them together on an I2C channel on the Arduino. I think I2C. Let me double check that and make sure I'm not completely making things up. That was what, 6064. 6064, I believe they're I2C. I'm on the wrong site. I'm on the learning site. I don't want the learning site anymore. I want the shopping site. There we go. So 6064. All right, that's that guy. I just wanted to double check that they are actually I2C. I think they are. So it's a yeah, right here, I2C interface. But they daisy chain together. So basically, the communication cable is coming from the Arduino into one of these, out of the other one, into, or out of there and into the other one. So they're daisy chained. So I need some room to basically get a wire with connectors on it in there. Now the connectors aren't very big, but you got to plan for that, right? Wires only bend so much. I couldn't, for instance, plan it to butt directly together. It would never work that way. So, like I say, that's the plan. And I just have to make sure we're spaced far enough apart. So let us head back to here and our chassis. And I guess we just sort of guess at a dimension between them that we want. 3/8. That's not very big, but also it doesn't really need to be. I need enough room to get the connectors in and to be able to bend the wires enough to sort of tuck them up in somewhere, right? Because, the pigtail is only so short, so it'll be tucked up, I don't know, maybe in here somewhere. I mean, I kind of like that idea. I kind of like where we're at. I kind of don't like how much plastic I'm about to add. So before I do anything else, I need the thickness of this correctly. Yes. Me speak English goodly. I need this correct, this thickness. Which means I want my board here So that is a 0.098, handy dandy calculator. 0.098, 25.4, and it helps if you use the right direction. That's a multiply, buddy. 2.5. Did we have a 2.5 millimeter somewhere? I'm trying to also commonize screws. I'm also trying to commonize screws, and I don't want to mix and match too many different types of, unless I can help it. So what was this? That's the smallest one we have in here so far, and that is an M2. So I think, and what was the diameter of this hole? Let's deselect. Deselect, what was the diameter of that hole? 191, that's even smaller, so that truly is an M2 hole. But I think we can get away with an M2 hole in a 2.5 millimeter, or an M2 screw in a 2.5 millimeter hole. In fact, I think that's probably the good plan. We're going to use M2s. We'll go with that. We'll go with that. So that said, we need to head to McMaster for our handy heat set inserts because I don't remember the depth I needed. We need not a 256 metric M2. And again, I go with the brass. I go with the biggest one because if the hole is deep enough for the biggest one, it will be deep enough for the smallest one, right? So depending on what I actually end up buying. So 4.7 millimeters, 4.7, 25.4. Again, helps if you hit the right direction for the conversion. 185. I'm going to call it a 1/4 of an inch. I'm going to call it a 1/4 of an inch. Now, in the case of these, I'm going to call it a 1/4 of an inch just to give about 70 thousandths of material behind it, so the inserts don't stick out. So I can set that right now before I forget it, and then I don't even need to write it down. Look at me remembering, good practices. So 1/4 inch. That gives us like 65 thousandths over what we actually need. That's great. And I think kind of what I want to do. Is I want to back these up a little. And I think I'm going to want those to land like almost even with the battery box. Well, forward, I mean, for line following, forward is probably better because then it'll catch the line a little earlier. But for layout purposes, I don't see that being feasible. I mean, I could come out, I guess, even lower than where those forward-facing sensors end up. I mean, that's not the worst idea I've ever had either. And they land in there, and that's actually going to get us away. That's actually going to get us away with the minimum material. So change of plan. I was going to make a big piece of plastic, something like this shape that I have. If you could imagine a line or a curve. I was going to curve it between here and here and make it nice and pretty. But I think what I'll end up doing is I'll end up extruding this. Well, let's get these out of here. Extruding this shape first to the height I need it for those sensors, and then adding material onto it, sort of in this neighborhood, to get those line followers, and even for aesthetics, I can center those between the holes, and that would look, I think, pretty good. Aesthetics, like I said, at this point in the design, I keep saying it's as much art as it is science, and it's what you think looks good, right? We're designing a part to be 3D printed. In 3D printing, with even a cheap 3D printer, I can make almost any shape I can imagine, right? So it's just making it, look the best I think it can look. And I think that's going to end up being the best, is going to be, if these are in this neighborhood somewhere centered, I will also line this up with the center of the holes. It'll be nice and offset back. I like it. Now, on these parts, the one thing I want to check, the one thing left that I want to check, I should say, I need the assembly, not the individual parts. There's nothing on the back of this board. Oh, there is. That's right. Well, no, because I'm using the I2C connector, I don't need to worry about those. There will be nothing in those pins. Like it'll be just like the, like if I look here, as long as you use the I2C connector, you don't need headers there. The headers are there if you're not using the quick connector, they call it. So that's going to be what we're doing. And why I grabbed a $14 sensor and not a $7 sensor? Like, what's the range on this guy? Does it tell me? 1.5 meters. Nice. So, oh, that might be what killed it for me. 50 to 100 centimeters is their sort of target. And the other ones that I grabbed are good for like 1.5 meters, a true 1.5 meters time of flight. So, I mean, that's really the reason I decided to switch off of these for the forward-facing sensors. But nonetheless, all that to say, I don't really have to worry about headers here, so I don't have to cut recesses in like I did for the big PCB. So that greatly simplifies my life. Back to the chassis. So knowing that I'm going to do that, I am going to delete these. I'm going to delete these rectangles entirely because they're going to do nothing but get in my way. Deselect that line. They're going to do nothing but get in my way for now. I now have a plan for them. I know where they're going to land. I'm going to get rid of them. I do want to position this guy. I'm going to construction line it to one of the holes. The holes are on the same line, so it doesn't matter which one. And I'm going to make you horizontal. That will lock everybody in. It's centered now. We got 45-degree view. We're actually pretty close to in line with where the ultrasonics will be. The ultrasonics are a little forward of that. But everybody should work out that way. I mean, yeah. So now I need to extrude. I'm going to accept this sketch because that's it. Again, I will, like in the future, I will come back and fillet everybody. I'm not going to leave it angled like that. It'll be nice and rounded, you know, with fillets sort of toward the end. But for now, like I said, this is dead space. Like I got to come out this far before I even figure in how much taller I need it. And that distance is 385. Handy dandy scratch pad. 385 it says. So we are 385. And that sensor board is 0.7 tall, right? Is that right? 0.7 tall. I'm going to give it an inch and see where it lands. I'm going to give it an inch and see where it lands just because I can. So total, we need 1.385. Now that might be too tall. We'll see where it lands after I extrude it. That's a distance that I can easily change. So total, I'm going to grab this. I'm going to extrude it a total of, what did I just say? 1.385. 385. 385. And actually, just for, you know, round numbers sake, I'm going to go 375. Only someone that is used to dealing with the imperial measurement system would you hear somebody say 375 is an even number. Like, that's a weird statement to make, right? Yeah. So, I mean, it kind of makes it look more car-ish, I guess, question mark. But, also, I mean, looking way ahead, this also gives us some material out here that we can maybe put some feet on, like those carriage bolts I talked about previously. Like, I'm not nuts about how far those stick down, but I have an idea. So let's get one thrown in here, shall we? Now, to get one thrown in here, I'm going to click here, and I got a sketch on this surface, and realistically, to get that hole pattern in here, I'm just going to go like this. I only need a rectangle, and I need, because I'm going to grab the points. Like, the points are the holes. I'm going to use the hole wizard, so just a rectangle with some points. I do need it centered, so grab a line. We'll construction line center here. Construction line. Don't forget to set it vertical and make sure you're in the middle. Let's go to the front view so everything's nice and lined up. And dimensionally, I was, what, 1 inch by 0.7? Oh no, mounting pattern is different, wasn't it? 0.8 by 0.5, right? Yes. Yes. And that is truly, I have verified it separately. That is truly, it's not like a metric measurement with conversion weirdness. It is truly that. It is standard units. So 0.8 on the long dimension point, not 0.8, 0.8, and 0.5 here. Good. Now, what I really want to see, because what I'm thinking is I don't need, well, one, I mean, looking at this, I went ridiculously tall. Somewhere I screwed up my measurement by a lot, right? I mean, we're almost twice as tall here as we have to be. So, one, my little, comment about this being way low is going to change in a minute. But I'm also thinking, like, the sensor itself, the board does not have to be below these screw bosses. The sensor does, and that means it could probably be up in here somewhere. So I'm about to start taking a look at some measurements to see about where that is. And if I just go shoot for the top of the sensor to the top of the board, and it shouldn't matter because it should be in the middle. So 262 there, 263 there. It's in the middle, right? So if we call it a 1/4 inch, right, that gives us 10 thou. I don't know how accurate this model is. Like if this sensor block thing is actually dimensionally accurate, I have no idea. But if I call it 260, I got to go the other way, 262. So if I call it 300 thousandths, like, well, if I just place, no, because I want this. So 262, I'm going to put a line in my sketch, and I'm trying to think of the best way to do this. I'm going to put a line in my sketch. It's going to be a construction line. And I'm going to put it 262 away from the top. That sounds like a winner. So this line now why does that not feel? Oh, because it needs to be from the hole. Important note. It didn't look right. It needs to be from the hole because that rectangle is not the board, it's the hole. So from here to here, and I don't want min, I want center. 162. 162, and again, not Alt-Tab. That's a SolidWorks habit. No Alt-Tab here. 162. That looks a little better. So this represents where the top of that sensor is. And now I want to define this whole position of this pattern based on this line, because I don't really care where this lands, right? I got all the material behind it that it needs. I don't care where it ends up. So can I dimension off of that surface is the question. That would be ideal. Like if I could say I want to go from here to here and have it be 20 thousandths, 30 thousandths, whatever. That would be ideal. So let's try it. Here to here. Will you let me? Oh, look at you. Let me grab a front view so I can just make sure that that's... So I have noticed, we need to be careful because SolidWorks doesn't do this. Onshape does. Whenever these are construction lines, as soon as I bring my cursor, it treats it like a diameter, which is actually kind of cool. I was doing a different part earlier today for another project and used that a lot. That comes in handy. So I'm not knocking it, but it's the thing to remember, right? This is diameter down here. We need to be up here. And we don't need 100 thousandths. I'm actually just thinking to start with 50. And that makes sure that like the top of that sensor block is below the screw boss, which means if this is in line, the ones on the side will be below as well. And if we look at the part number, which was not 6064, what was the actual part number of that? I don't remember already. Check the download history. 5396. 5396. Like the actual sensing thing is also below that surface. So for 50 thou low, the actual sensors, which are these dots, right? One's an emitter, one's a receiver. That will actually also be lower by that little bit. So 50 thou should be good. And that's sort of the thought process I'm using for that idea. So yeah, I'm going to call it good there. I'm going to call that sketch good. Now I want to measure from here to here and see how much of this I can cut back off because I way over extruded. So we're 0.602. I can cut off at least a half an inch of that. Like at least. What extrusion was that? Down here, way down here. Extrude, edit. 875 should be less half an inch, right? 0.875. So again, this won't be vertically centered here, but that's not the important thing. And we probably don't even need the 875, but honestly, now that we're back sort of in line, I'm curious, is that exactly how tall the battery was? Yeah. So it's exactly in line now with the battery compartment. This bolt pattern won't be centered vertically here, but that's not the important part. The important part is that this construction line, the sensor, the board doesn't need to clear, but the sensor does, and it should if things are okay. Now, I'm going to get kind of spicy. And this is me just wanting to play with Onshape. I'm going to basically duplicate this sketch on these other two faces. And I want to see, I'm doing it for a reason, I want to see if I can put holes on all of those sketches all at the same time. Like, I don't think SolidWorks will let you do that. Like, you have to use only one sketch. I could be wrong. I've honestly never attempted it. But I want to see if it'll let me do it here. So I'm going to do it. And I already forgot what our bolt pattern was. Can I just set these equal? Will you let me? Equal? Hey, look at that. I like it. Equal. Equal. Now, can I also put them in line? Because that would be cool. Not horizontal coincident. Yes. Awesome. And then all I have to do is center the thing with a construction line. Except I screwed up. I screwed up an equal somewhere. My rectangle is not nearly long enough. This and this are equal. This and this are equal. All right, I'm getting the impression that the equal thing is not working out the way I wanted it to. What if, let's undo. All right, so we're raw, we should be pretty unconstrained. What if I make them in line? I'm just trying to cheat, also playing and seeing what Onshape will let me get away with. All right, so I just made these in line with these. And now what happens if I make, well, let's try the top. The bottom one clearly didn't work. Yeah, see, it doesn't like that equal, which is okay, I guess. I just have to get that dimension. What's the length of this? That was the 0.8. Here, 0.8. I don't need to worry about my construction line across because I already set it along the same perimeter, set it along the same height, right? So it should land in the same spot. So we should be good there. I just have to center the thing. I will need a construction line for that into the center of this guy. Construction and vertical. Cool. That sketch is done. And then the same thing over here. Sketch, rectangle. Might as well set the width first, I guess. So that's the 0.8. And then set these guys in line. Coincidence. In line. Coincident. In line. And then a construction line to center it. Construction line to center it. Be vertical. And then be construction. Okay, and then that sketch is done. Now what I did all that for, why I did all three of those at the same time, is I want to see if I can do this. Do a hole. I was playing again earlier with different sizes. That was a number 30 drill bit. Right, double check my McMaster drawing. Number 30 drill bit, 4.7 deep, 0.7, 25.4, 185, we'll go 200 deep. So termination blind, 0.2 is already there. Make them flat just like every other one. Now sketch points here, 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 here. Oh, that's lovely. I like it. I like it. And that's exactly what I wanted to see. And it would let me do all of those sketches at the same time. That's kind of awesome. So, except that, that's good. Those are all my screw holes. Now, I think I'm okay with that. Because again, if these were pressed in, I would want more material there, because what will happen is as you press, you're sort of by definition moving the base material. A press is an interference fit. That material's got to go somewhere. The heat set inserts we're not pressing in, we are heating, and the plastic around them is liquefying to make room for the insert. So we should not need as much wall, and we shouldn't get bowing. Now, I'm well aware of what I just said there, and that the word should is very strong. So that's really one of those things that I'm not going to know until, we build one. We know for sure until we build one. So, but I do kind of like that. I do kind of like that. I'm kind of happy with that. Well, the question was in the back of my head. I'm sort of now one thing to pay attention to that just hit me before I have that other aside thought. As I was spinning this around, one thing I noticed, we want to make sure that in all the fanciness that I just did, we can still get at these with a screwdriver, right? All the plans in the world kind of fall apart if we can't actually get to these. One, to put the inserts in, two, to, get the screwdriver on them. So that should have plenty of room for both. The soldering iron, honestly, might get a little tight with the heating tip on it. I kind of live with that. I think we can get it in there, even though it'll get a little close to this. And besides, if that's a worry, these are definitely worries, because those are a lot closer to the walls than the other ones. And plus, I mean, I don't necessarily need to heat them all. I have had good luck with these types of inserts in the past, just pressing them in. They do hold pretty well if you just press them in. The knurling really does a good job of holding. So I might be able to get away with that if, when I go to assemble these, I run into an issue. But yeah, so like I said, I kind of like that. I kind of do. I'm kind of happy with that. I do want to make this transparent quick and just check that those holes have enough backing. I think they do. I think that's enough. And an important thing that I got to keep remembering is, until this is finished and I actually get it, realistically, until I get this in the slicing software for the 3D printer, I'm not going to know what direction I want this on the print bed, right? I don't know. I have no idea yet. And so, I mean, some of these walls the walls on the bottom of these screw holes might be too thin, depending on what direction it's on the printer. I just don't know. So it's a thing that we'll have to work out later. That's just sort of the nature of it. Now, I need to get those other sensors in. And looking at this, so what I was going to say is I kind of like how this is even with the battery compartment. But we had already talked, or I had, I'm kind of the one doing all the talking, right? I had already talked about how I'm going to make the battery compartment, or at least part of it, taller for that RFID sensor. So it will officially no longer be the same height as these, which means if I add material on the bottom for those two downward facing sensors, or even in here, it's not really going to make much of a difference. So, I mean, I might as well come off of this and go sort of up for those line followers rather than forward like I had talked about. Come up, put the line followers in this pocket where I sketched them originally, and the RFID toward the back. And given that this thing has two drive wheels, the way it turns is by counter rotating the wheels. It's effectively zero turn. if the RFID is back here, sort of centered between the wheels, then that actually works. Centering it between the wheels, that way the zero turn takes effect. When it sees an RFID tag and makes a turn, it will truly be at the intersection of two lines, which, I mean, in the immortal words of the great Bob Ross, is a happy accident, but I'm very cool with it. So I'm going to do that. We'll plan on that. We'll shoot for the RFID sensor to land here, and those two color sensors, line following sensors, will just basically extrude a new rectangle from here out, up toward the toward that angled mounting area. And I like it. That will work out, I think, very well. That'll work out, I think, very well. So, yeah, let's do that. Now, the difficult thing that I have found, I tried to do this once before, is that is the one thing, because now you'll notice Amazon here in their bill of materials, in the students' bill of materials. The ultrasonic sensors originally came from Amazon, but honestly, you can buy that part number with that basic, that HCSR04. You can get it just about anywhere, so it's not hard to sort of find solid models of it. It was a lot harder when I went looking, and I got to look in this list. Where is the RFID? It was a lot harder. This guy. It was a lot harder to find a solid model for this. So let's hop over to Amazon. Amazon. It was a lot harder to find a solid model of that. So it is literally this. I could not find these. The students could not find these on Adafruit or Arduino, sort of the major players. So we went with Amazon. But now that I'm saying that, I wonder, what I just typed in is probably best to use this, RC522, I'm going to guess, because that's probably the manufacturer's part number. The number that I pasted from their bill of materials is probably the manufacturer specific. But what if I looked for that? RC522 solid model. You'd be surprised what you can find. Look at that guy right off of GrabCAD. RC522 module. Look at you go. Awesome. I mean, there's a couple of them here. Even, do I need to be signed in? Because I'm not sure I remember my GrabCAD login. That looks an awful lot like the one we're looking for. Pop back on Amazon. So up by that, the part number there and the screen printing, those holes should be closer together, sort of inside the RFID antenna, and then the two mounting holes are sort of on the outside, on the opposite end. Outside, inside. I mean, this looks like our guy. That's an ad. Because I mean, I gotta be honest. Like, why? I mean, I've seen ads do some scammy things. This is like one of the worst ones. A big download button is an ad. But we'll download the files. Yes, I'm going to have to be logged in, which means I'm going to have to guess. And I don't mind that it's my email being shown. Because, frankly, I mean, hey, look at that. I remembered. Yeah. Don't save that. I reuse the same. I break the ITU rules, right? I use the same password. So show that file, extract that file, and what do we have actually in there? We do have a step file. So let's see. And I'm guessing we're going to get all of this because he rendered. Whoever made this, I just assumed, which I shouldn't have done. Unit Electronics. I shouldn't assume, but I'm assuming they use a solid model for rendering. So let's, I mean, we don't have anything to lose. Let's bring it into our model here. Again, I'm not going to do composite. It didn't help all that much, really. Now this one does, I do remember that much, does have, I can't rotate this picture, does have header pins. This one we will have to remember to cut in a pocket to give those somewhere to go. So yeah, are you done bringing in my, nope. We are post-processing. That should mean it's open, I think. Imported with errors. Now, honestly, I don't care. I gotta be honest. I do not care much that it came in with errors. I don't know what those errors are. A faulty topology. So that means that when it brought the step file in, there's probably like an overlapping surface or something funny. I don't care. I mean, if I were modeling it like and it gave me an error like that, I would chase it down and freak out and all kinds of stuff. I don't care. I mean, it is what it is. And well, one thing I haven't actually checked, like SolidWorks, when it does that, has a wizard that can try to fix some of that. Does this have that? Switch to parts. So I probably want to be in here. And what if I right click this? I don't want to switch to the step. I don't want to add an appearance. It's already got appearances. I kind of like that it has appearances. Edit healthy moment? I don't know what that means. I don't want to do that. No. What if I click the individual parts? I'm just looking to see if there's something that's like a heel, right? Because, yeah, I can't do that. One feature failed to regenerate. Yeah, well, that's the feature because all of these parts failed. I'm just going to go back to my original saying, or my original thought and say it doesn't matter. And I'll leave them broken. But what I do want to do is I do want to do the fix group trick. Like, what happens if I delete all that stuff? Is it? No. I was going to say, is all that somewhere else, but it's not. Like, if I select, that one's not faulty, but if I select all the faulty stuff, yeah, including the PCB, great. So, again, doesn't matter. Don't care. Fix that guy. Group all these together. And I'm going to hope I can do even the assemblies. I haven't tried it. Group. Did it select them? I mean, it kind of looks like it did. Header, they're in there. Accept that. Now, in my assembly one, I'm going to bring it in. Insert. I'm just going to bring it in. Whoops, not other documents. I want assemblies. And I want PCB modulo V263 PCB. Are we not alphabetical, or did I just blow by it? There it is. Bring this guy in here. I'm going to throw a quick parallel mate just to get it oriented right. Flip. Okay, just to get it oriented right. And now is the time for another command decision. Like, what direction? Because these holes are not symmetric, so it's going to matter what way it goes. One, I want to target this thing to be between, like, dead center between the wheels. I think, because then, if you think about it, when we land on an RFID tag, that means that RFID tag is dead center between the wheels. When this thing turns and the wheels counter-rotate, it acts like a zero-turn device, which means it would be zero turning right on top of the RFID tag, which is about as precise as we could ask for. So I think I want the dead center of this RFID antenna, which is conveniently this circle. So that'll give me a feature that I can plan off of. Like, I can get the dimensions, I can get the hole pattern, and then dimensions to that, and use this to line it up. That's the plan. Now, but the question is, what direction do I want the cable coming out of? Basically, being front or back. Back, we got to get here, which means I think I want to come out the back, with the plan being the cable will route up through here, and I can even add some plastic, like a plastic, sort of half cage here to hold it, so it dives into a little plastic tunnel, back out, and plugs in. I like that. That keeps it out of the way of the battery, so like the battery can be changed without that cable getting in the way. I like that plan, I think. Now, the next question is if I can do that, manage to get this centered without hanging out the back, because I do not want to do that. And worst case, in that scenario, we just shift it forward and live with it. Because I do think the cable, this is one of those design decision things. I think it's more important to get the cable coming out the back than it is to have this perfectly centered. I think. So, again, temporary parallel mate. I will delete them eventually. I'm going to parallel this with the front of the battery box. We're going to flip it. Good. Grab you, drag you back up here. All right. So, yeah, we're not going to quite get where I want to be. In fact, I'm going to intentionally do it. I want to have some room. I'm intentionally going to go to the front of the battery box and just line it up there and be happy with it. I could even come further forward if I want, but what I want is I want room to be able to plug in, and this is what, an 8 ribbon cable. I want to be able to make this little bit of a turn and come up through, what's it going to be on this side? So make this little bit of a turn up into this channel and back up here to plug in. So to do that, especially with an 8 ribbon cable, we need a fair bit of swing. It's a hard thing to judge exactly how much swing we need. It's a hard thing to judge exactly how much swing we need. So I think I mean, there's no good way to know. There just isn't. Like, we're going to be a little out past the end of these pins because of the connector on the ribbon. Those ribbons don't turn real sharp corners. Also, we got to consider that it's going to be hanging down a little bit. I was going to say, I might add like a loop of 3D printed plastic here to run it through just to make sure it doesn't drag on the floor, but I don't know if that's entirely necessary. I mean, for now, let's get the thing mounted. And honestly, somewhere in this neighborhood, because if I come back flush, like I said, well, let's go flush. I mean, the joys of 3D printing means that in a couple of hours, if this doesn't work, I can always move it in a couple of hours, have a new version, right? Let's go flush. Let's plan for the leading edge of this board to be flush with the existing battery box. Okay, that will be the plan. Now, how thick is our PCB? Because I am gonna inset it, and in fact, I am gonna inset it just like we did the boards on the top. Board for now. These LED boards will get inset. This board is inset. I believe it was 63 thousandths thick. How thick is this? I'm going to guess the same. Well, there we go. Why don't you let me select a surface? Select that surface. Select this surface. Oh, because I'm in a mate. Did I never accept that mate? That would be tragic. Well, either way, it kept the orientation. They're temporary mates anyway. I will get the screw holes in there and then mate based on the screw holes when the time comes. But what I want to do is I want to add enough material to inset the board, and I need to cut in for these pins here that stick out the bottom, and I want to inset this whole connector, I think, plus a bit so that at least the plug-in there's plastic there. It's it's like protected-ish. Not perfect, but it's got some non-wire material between it and the ground. How about that? It just feels right, and I'll do that now, and I'll show you why I'm thinking that way. So to do that, I probably want to jump to this first. I want to get a height. I want to get a height of this, and I want to get a height from there to here, right? Because that is the minimum inset I'm going to do. 321. I'm going to call it 375 because that's the way my mind works. So 375 for an inset, right? That's plenty. That's plenty to inset us. Well, that's. I need I need that much material for an extrusion plus threaded insert material. So now threaded insert, how big are the screw holes? That's the question for the insert. 126. And if we go to metric, 25.4, hey look, I remember, so 3.2, we're going to do a 3mm hole. 3mm thread. So heat set, we're going to go back out to 3mm, M3. Again, I like the tall one. Ooh. In this case, I don't like the tall one. I don't like the tall one because half the quantity, almost the same price. That means the price is double. I'm cheap. So I'm going to go the next one up. In this case, I'm not going to design for the tall one. We need a number 22 drill. 6.5mm is 6.5. Call it a 1/4 inch. When we have some material there still on the bottom of the battery compartment that we can encroach on, we won't be in the battery. So if I call that a 1/4 inch, and where did I write? This is the problem with my scratch. So 375 is what I needed for height for inset, and a 1/4 inch. 0.25. Looks a lot like 625 to me. So let's do it. Let's do 625. Now the question is going to be, how ugly is it going to be sticking out with a big 625 lump under there, another 1/2 inch. So let's go to the chassis. Actually, I probably want a few more dimensions off of this thing first, right? We need more. We're going to need more material out here for the inserts than between here and the edge of the board. But I'm going to get the board width. I'm going to call it 2. 1.553. I'm going to call it 2. That'll give us enough material. So 2 by. Now, I do not need to go all the way out here with plastic, even though I plan on insetting it. So I should be able to get away with just the board. And we should have plenty of material because these are so far in and these are so far in. So 2.362. I don't even really need to be that big. Like for instance, what is here to here? Here to the front is what? I don't want minimum, I want center. 1.74. So if I go 2, I'll try it. I'll just try 2 by 2. Try a 2 by 2 square. 2 by 2. And then I'm going to do a quick diagram of the hole pattern. Hole pattern. So center to center is what? Parallel axis. All right, I'm almost going to guarantee that that's metric. When you see a weird number like that, I'm going to almost guarantee it's metric. So if I do 1.019, and I'm not going to use all those decimals because I'll rerun through, I think in episode 1 or something, I did this conversion for maybe the power board, where you just sort of guess, and it it tends to come out right. So 1.019 inches, 25.4 to get to millimeters. Remember to multiply, not divide. So 25.8. I'm going to guess that should be 26. 25.8826. going to guess that that should be 26 millimeters. Because 26 millimeters divided by 25.4 is 1.02. That's not quite, well, I guess I could do it the easy way. I mean, I'm trying to show you, 25.88 millimeters, and that's on the nose, right? That's about exactly what I came up with. So 25.88, that's odd. That's just weird. But I actually need a new piece of scratch paper. I mean, what is this, episode 6? Finally filled a piece of paper with random scratched dimensions. So here, 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 here. I just draw, I don't know, we can see it in the light. I just draw a sequence of dots, and then I'm going to put dimensions on them. So between here and here, we are at 25.88. 25.88. And then I set a 2 by 2 square around this. So now here we go. These are what part? And we're still in millimeters. Center distance 34.25. 34.25. And then they are in the same lines, so I should just be able to get a dimension, one dimension this way. Parallel axes, and I want, is Y the right direction? Yes. 37.45. Vertical. 37.45. Vertical. Now, I was going to go off this center dot to try to land it in a certain spot. I do not believe I'm going to be able to get there because just eyeballing this, center of the wheels is going to put it somewhere way back here, hanging out the back. So I think that original plan that I talked through is not going to work. I am going to just line it up with the front of where the battery box is now and call it a day, take the L, and get out with some dignity. That's sort of the plan. So let's head over to the chassis and get that sort of mocked in there. So I want a bottom view. I want to select that. I want to sketch on it. We're going to make a rectangle, even with that front. And I realize I made it too long now that I did it because these need to be equal, but this is going to be 2. And this is going to be 2. And I don't think we actually need 2 by 2. I think that's going to be way wider than we're going to need. But can I just midpoint off of this? SolidWorks would not let you do that. Yep. Nope. Nope. Okay. We'll do the construction line method. Line. Well, I don't really need a construction line. I can do it with a point. So there's 2 ways to do it. Since I'm coincident with that already, like I'm coincident with this top line, first I usually try to, I like want to get this way out of space somewhere so that I can put a point on the midpoint, and I know it's now on this midpoint and not on this midpoint, because now I want to find that midpoint, and to do that I think I need to get that dimension out of my way. There we go. That midpoint there, make them coincident, and we will be centered. Everything's locked down. Good, except grab that sketch and extrude it a whopping, what did I say, 625. 0.625. Ew. Ew. And then, I mean, at that height, I'm going to have to seriously question whether the wheels are going to reach. I guess we can find out right now. Like, are we going to bottom out? We are getting dangerously close to bottoming out. Way more dangerously close than I wanted to be. But that's a thing, I guess. So now, that's a thing, I guess. Now we inset, and we need to inset. We need to inset it. What did I say that was? That was 375 before we even get to inserts. So, wait. So I think I misplanned the entire thing wrong, because 2x2 only, like, it's wider than 2. There's nothing to inset. I didn't leave enough material to inset, so I might as well forget the inset idea and just leave these guys hanging out in space. There's just not enough material, because 2 inches came to like here, right? Which means if I, quote, inset, I'm just going to cut away everything I just extruded. So I don't need that extra 375. I just need a 1/4 inch. Yeah. Yeah, I tried to get a little too fancy and changed my mind somewhere along the way, and it didn't compute. So edit, I really only need that 1/4 inch. Just the 1/4 inch for the inserts, right? And then I can cut into the, actually I don't need to cut into this, because yeah, I don't need to cut into this for the purposes of insetting the connector pins, because they're going to be hanging off of the back of this platform anyway. So there was a whole lot of extra calculation there that really doesn't matter. So let's get the holes in and get this thing mounted and get on with life. Easiest way to do that is probably with a couple of lines, since it's not a rectangular pattern. A couple of lines and construction lines to hold it all in, centered about the things we want it centered about. So here and here, this line and this line we want vertical. They don't really need to be for construction, because we're only using the points when we make holes. But this one, if we space this out, that one needed to be 20. Wait a minute, which end are the narrow holes on? That's something I do need to double check. Narrow holes are on that edge, so that one is 25.88 millimeters, 0.88, and in Onshape as well as SolidWorks, if you type in mm, it will give you like inches here, but that is truly, if I double click, it's truly metric. So just remember that you can always type in mm, if you only have a couple of dimensions. If the entire thing is metric, whoa, I forgot mm. 34.25 mm. If you only have a couple of dimensions that are metric, that's definitely the way to go. If the whole thing is metric, I mean, by all means, change like the dimension standard of the entire model and just, again, I forgot mm. 37.45 mm. That's good. Now, how far back were these from the front? Again, with the Alt tab, let us not Alt tab. How far back are these from the front? Because there's going to be plenty of material from here to this edge to get an insert in. That's really all I am concerned with. And that's plenty, so I can go ahead and use a center distance here, which is 6.78 millimeters from the front. So this where's my dimension? Right there. And this distance was 6.78 mm from the front. And that gives us plenty of material all around for screws, or for threaded inserts rather. So now, what does that insert need? That insert needs a 22 drill bit. 6.5 millimeters deep is 6.5, 25.4, 1/4 inch. It's a little deeper than a 1/4 inch, but we'll get away with a 1/4 inch. Hole Wizard 22 drill. 22 drill. That's an odd size. What did I grab? An M3. 22 drill. Blind. 0.25 deep. Flat. And then we start grabbing points, which is going to be here, 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 and here. And these two, I'm going to go transparent again after I pop these in here, because I want to make sure, make transparent, where are you? I want to make sure I'm not in the battery, and I'm not. I got plenty. I mean, look at that. It's sort of filthy how much I've got. In fact, I kind of want to make that thinner, but I think if I remember right, we already sort of made this about as thin as we wanted to go. Yeah, 120 thousandths, eighth of an inch-ish was the target. I don't want to go much thinner than that. I don't think the battery is by far the heaviest feature in this entire product assembly. So yeah, we don't want to do that. But now let's get this bad boy. Well, I mean, I did want to well, no, because even if like I said, even if I recess this, I can recess the PCB. I just don't need to recess, all the way down to the connectors. But I can recess the PCB and make things pretty, and I might do that. Let's do that. At least get the PCB. Well, no, because even if I recess that, I'm trying to think. Even if I recess the PCB, then we run into another issue where, like, I'll have to recess all the way out here in order to get inserts in. I also don't need that to be 2 inches wide. I think I can, fix that in a minute. I'm going to get this. Let's get this permanently mounted first, or something resembling permanently mounted, and then we can play. Parallel. All right, that was a motor mount? No, that was to hold the light in place. Oops, this parallel should be for that board. I'm going to delete it because I'm going to mate based on holes, on mounting holes, not based on parallel surfaces. So we want revolute, because that'll lock us down into dimensions here and here. Okay. All right, now if the math and measurements were correct, first I want to swing this out of the way. I always like to swing it out of the way and let the mate swing it back. That just double checks and make sure everything fits. Here and here, and it should. Hey. Oh, no, see, so the fact that this is red, even though it swung it into position, which is weird, like SolidWorks would have just plain freaked. That tells me that something ain't right as far as measurements go. So I'm going to delete that one. I'm going to check and see if I get lucky by mating this hole. Probably not. Probably will have to end up doing a parallel mate and cheat it, because we're close enough. Like, so if I accept that, so it likes those holes, it's just those other holes. I mean, we're close enough. Like, you can tell if I make this, can I make this transparent? Like, we're not concentric at all. I was going to say we're about as concentric as we can get. There we go. No, we're not. We're off by quite a bit. All right, let's get rid of that. Let's get rid of that. Let's take another measurement. Hole to hole is what? Center distance, 34.25. That's what I set my holes at. 34.25. Let's double check the sketch and make sure. Edit. 34.25 millimeters. I mean, right? Did I miss something? Here, here, here. 34.25 millimeters. Okay. What about the holes underneath it? I'm sorry. I mean, am I missing something? These are the things that make you wonder sometimes. And measure that in 34.25. Except, like, I'm 100% confident that those holes are not concentric, even though they're showing the same center distance. So what did I miss? Am I going nuts? I mean, I guess mention in the comments if you can see what I missed, but those are definitely, especially if we make sure we're at a bottom view, so we're looking straight on, like, those are definitely not concentric. They're also definitely measuring the same. So here, let's grab the whole cylinder maybe of the PCB here and here. 34.25 millimeters. Grab a bottom view. Make sure that looks right. Right. Make sure it's going center to center, I should say. center to center, 34.25 millimeters. And if I hover over it, it is exactly that. Like, there's nothing hiding. Now, if I go cylinder to cylinder on the screw hole, 34.25, and it is that. I mean, every once in a while, I guess you just have to take the loss, but this is going to bother me. Why are we off? I mean, another option would be, I don't understand what's off about that, but I'm going to fix it. I am going to fix it because it's definitely off. Like, these lined up, it let us mate those. Well, plus, I'm also trusting a random 3D model that I downloaded. I mean, I don't want to insult the creator of said 3D model, but I'm trusting a random model that I just grabbed that happened to match the part number that I'm using. Let's be real. So I'm trusting that, but the fact that those holes don't line up really bothers me, especially since, you know, measurement-wise they do. So what I'm going to do is I'm going to edit this sketch and just delete this measurement, and I'm going to do an in context on these points. So I need to get out of, so there's no, like that sketch, the minus sign, it's underdefined, right? So now I can edit this in context. I honestly don't know what different contexts do. I'll be honest with you. Not used to that. But I can edit this, and I'm going to make it just concentric. I'm just going to straight up grab that and be concentric. Where are you? Concentric. You can't. Why can't you? Why can't you? I'm sorry. Edit. All right. What if I get rid of that? Maybe the height is what's off? Maybe it's like a triangle problem? I'm sorry. What's the problem? Concentric. All right. It liked that one. It moved the other one in because, of course, we centered it. So if I accept that, now if I go to the bottom view, it's, now that one's off. Are they not centered? I never checked that. I never actually checked that. I'll bet. Yeah, I'll bet. Let's do that. Edit, undo, undo, undo. I'm back to constrained. So all my dimensions are back. I never checked to make sure that whole pattern was centered. Like maybe it shifted. It doesn't look shifted, but maybe. So edge to edge, we can use minimum this time, I think. 039. 039. Let's get more granular than that. So the distance, that's X. It's a millimeter. It's a millimeter. Oh, I'm not seeing why holes don't line up. So I'm straight up not seeing why holes now are these the same, like edge to edge. Maybe those are the ones that are off. 5.22. Aha! Those holes are not centered in the PCB. These are. So, what do we do about that? What do we do about that? What do we do about that? We edit the sketch. Edit. Edit. We edit the sketch. This dimension's correct. This dimension's correct. This center is not. So this midpoint. Yeah, actually, let's delete this whole line and this whole line. Because this bottom one, the longer, the wider spaced one is centered. Right? And I like whatever dimension that happened to land at. Actually, why is that movable? Something's movable. Why? Something's blue, that means something is movable. What's not defined? Okay, you're not vertical. All right, I was guessing that. Vertical. That's fine. That's good. Now, this should be able to move side to side, which is what we want because it needs to be shifted. And I think the easiest way to shift it is going to be based on this hole. So I'll measure basically this dimension from here to here in the X direction and base that top line on that dimension. So here to here, hole to hole, and I want along X 4.32 millimeters. 4.32 millimeters here to here. And I got to make sure, this is one of the tricky times where you got to just make sure you place your cursor in the right spot. 4.32 millimeters. We're not quite centered. Let's go with that, see how that lines up. Let's go back to our assembly. Now I'm going to delete the revolute that actually did lock it down, because if things worked out, I should now be able to go opposite hole. And I mean, you're witnessing a thing that I usually try to do. When I mate a mounting pattern like this, I try to mate opposite holes for just that reason. And there we go. Now they line up. So it was just shifted. And if I, again, do a double check, get a good bottom view so we're straight on it, transparent to this guy, concentric, 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 and concentric. Now, if we're off a little bit, like let's say the model I downloaded isn't perfect, I mean, because again, I don't want to insult anybody, but I'm trusting a model. It was the first one I grabbed. If we're not perfectly concentric, a couple of things can happen. We can shoot for, I mean, let's face it, we can shoot for 3 out of 4 screws. That's not going to kill us. We can print another one with the right dimensions. That's not going to kill us. We don't have a lot to lose by doing it that way. I mean, we just don't. So then what I want to do, I want to make double sure that I want to go transparent again and make double sure that we're not encroaching on the battery. We're not. In fact, I could probably go thinner in that space. Like, we're only spaced that far down. We're only that far down. I want to go to a left or a side view. Yeah, see how far down that connector is? We got a lot of wheel there still, but I'm not nuts about it. I want to try to squeak that RFID sensor up as much as I can, which means this is going to get thinner than 1/8 of an inch, but only where those holes are. So what did I shoot in other places? Let's go back to the chassis. What did I shoot for thickness in other places? Like here to here, say. What is that? That's 100 thou. Well, so I didn't cheat it much. What are these? 125. I went for 1/8 of an inch. I suppose I should stick to my own design principles, right? And leave that at 1/8 of an inch. Leave that hanging down out in space, all nasty like that. And just get on with my life. Just get on with my life and go about my business. Probably the way to go. Now, I'm thinking right now, well, one, I'm thinking it's getting late. I am going to try right now to get those other 2 color sensors in, or at least get the mounts in. And it occurs to me, those other 2 sensors do not, like this needed to mount here because the RFID needed to mount here on the battery compartment because, I mean, frankly, where else is it going to go? It's freaking huge underneath here, right? Where else is it going to go? Those color sensors are kind of small. They will fit in this area somewhere. I sketched it in already, right? They fit. I'm thinking, honestly, now that I'm looking at things, I'm thinking of keeping those up in this pocket as tight to this surface as I can. Because everything I just added is a natural light block. Those are color sensors, or light, I should say, light intensity sensors, right? Ambient light is going to screw with those something fierce. If, however, we kind of shield, I mean, it doesn't help shield the ground. Like if too much light shines, if we're following a black line and too much light shines on it, they're still going to lose the black line. It's kind of a thing. It's a thing. But I'm thinking if we tuck those up in here nice and tight, at least they're kind of in the dark-ish, right? It's acting like a natural sort of shade, and that might help them function better. It's a theory. Like they have the range to see from here down. That's not an issue. Um, what was it, 50 to 100 millimeters? It said, I think. I probably need to back up a few pages. This guy, that's what they said to shoot for. 50, so basically 2 to 4 inches ish. So we'd be kind of in the sweet spot better anyway, the higher up we went. So I like that. I'm going to tuck them up in this pocket, formed by this mount here. I'm going to tuck them in there as much as I can. So now I need to go back and double check exactly what. Let's go to the chassis. Let's go to the chassis. And let's I get rid of the. Oh, well, it was the same board, right? It was the same board as. Wow, I gotta go in and clean some of this stuff up. The same board as this, different part number. Oh no, this is the light sensor. The time of flight was the one that had the symbol. So this is the right one. This was 0.8 by 0.4, 0.5. 0.8 by 0.5 is the mounting pattern. The board, I think, was 1 by 0.7. 1 by 0.7. Oops, got to deselect those other sides. 1 by 0.7. And there we are. 1 by 0.7 is what we need. We need to tuck that up in the chassis on this surface. Let us sketch and do this. Dimension that as 1 by 0.7. And I mean, the thing is, I was worried about wires earlier. The thing is, well, one, I can come basically all the way back here, close to it, all the way back to the battery, and as far out as I can go. That gives me like the maximum width while still being tucked up in here. But at the end of the day, I don't need enough room to like get my fingers in here to plug them in. I can plug them in together and then mount them. So that's not the concern. The concern was just just to have enough room to get the wires looped up in here somewhere and tucked out of the way. So they got somewhere to go. So that was the concern. 1 by 0.7 though, I'm almost positive we're going to need a little extra. I'm going to set this, and this to construction. Is that what I want to do? Yeah, I'm going to set that to construction because I'm going to build a bigger rectangle to account for the fact that we got to get inserts in it. So this is probably going to be 0.875. And if I added 175, I'm going to add an eighth. I'm going to start by adding an eighth of an inch to this. And that's going to be the defining rectangle. That is not the whole mounting pattern, but that is the defining rectangle we're going to use for a platform to put these on. Because we need a platform, again, same with everything else, we need a platform tall enough for the threaded inserts. So I'm going to make this and this. I'm going to line it up right with the battery box. We might as well. It's right there. We'll make it coincident. And I'm going to try. I can't say it's going to work. I'm going to try to make it coincident with this edge of the battery box as well. Coincident. I mean, it's kind of iffy. I'm going to be honest. It's going to be kind of iffy because it's going to get so close together. I'm a little worried, but we'll try this and see what happens. So again, here, these three edges are for construction. Then I'll connect them with actual not construction lines, but they're coincident and equal. You deselect. I do like how SolidWorks keeps things selected for multiple sort of constraints like that. Let's make that coincident. So that's what we're looking at. How far apart are we now? 1/4 of an inch. Where's my handy dandy calipers? I need to visualize a minute, knowing, I mean, those wires aren't very big. 1/4 of an inch. Honestly, I mean, it might be hard to visualize if I just hold the calipers up to the camera, but I don't have a banana for scale. But 1/4 inch should be enough. Should be enough. That is a big should. That is a very, very big should. I'm also concerned about how that's actually encroaching on. So maybe height-wise, since I just guessed and added 175, maybe we make this and this coincident. And just let it be what it'll be. So you got just very, very slightly shorter, but the alternative was to let it pierce that and extrude up, which it really wouldn't have hurt anything. Just somewhere in the back of my head was telling me that probably wasn't a good idea to leave it encroaching like that. So I'm just going to enclose that with a box. And then I need to check, that was an M2, I think. I mean, well, what did we use here? Same mounting hole. Let's edit, because it doesn't tell me the drill bit. So it was a 30 drill bit, 0.2 deep. So we need, I mean, realistically we need 0.2, right? This sketch has to be extruded 0.2. Extrude 0.2. Right? I mean, we want to keep it as tight as possible. Those boards, they don't need to be, why are you red? You're red because you're encroaching on that? Is that what you don't like? What if I merge with all? Yeah, it doesn't like that. What does it say? Did not regenerate Boolean operation in non-manifold body. I will admit, like, I have taken some pretty advanced CAD courses. I will admit I do not remember what non-manifold body is trying to tell me. I'm willing to own that. What I am going to do is edit this sketch. I'm going to delete this coincident. I'm going to see what happens if I make it bigger and make it encroach the way I had it in the first place. I have a feeling the problem is it is contacting exactly that point. 0.875 is what I had at. I have a feeling it was encroaching exactly at that point. Now, it should be ever so slightly piercing it, which should, no, you still don't like it. Add it. Do I got to get taller? Like, do I got to, because it's so close. Well, so close doesn't matter because CAD, remember, CAD is exact. Like, I don't care. I don't care whose CAD you're using. CAD is exact. So I'm going to go even taller. I'm going to go an inch. Well, now, wait a minute. Why did you pull in? Why did it pull it in that? Did it not delete that? Because you're still coincident. Where's the coincident? Is that the coincident? No. Which one? Which one? That's the coincident, right? Delete that. That's why. You need to be now coincident with that edge. Let's go back to the 0.875. Now, an inch we might want to be at. I will say that. All right, so we got our extrusion. We are ever so slightly pierced. Notice it's a little flat. We are pierced there. It should be equidistant. I hope we're pierced there. And actually, I probably do want to make it a little taller. I want to pierce it more because eventually, like I said, I'm going to pretty this up and fillet everything, and I think I want more meat there when I do that. Yeah, probably. I mean, it won't hurt anybody. That's filling. Yeah, fillet. The fillet will add more material. Let's leave it there. let's leave it there. The fillet will add more material. Let's go ahead and sketch on that bad boy, and we need just a couple of rectangles, right? Rectangles. We will line them up. Coincident that, and we will equal top, equal the sides, so we only have to dimension one of them. Equal. We were, and since I didn't write down any dimensions, we need to double check spacing. Spacing 0.5, 0.5, 0.8. How's my memory? Memory's holding on. 0.5 by 0.8. Dimension 0.8 on the long side. And again, these are truly standard measurements. They're not like those sneaky metric ones they try to sneak in on us every once in a while. And actually, I mean, we'll see how it looks once it's assembled. Kind of thinking we don't need to even encroach on this platform at all. That's kind of what it looks like. We do want these close together, so I mean the width, we can space them out a bit, like as much as I can stand to space them out. What is the diameter? 157. I'm going to throw a construction circle in there. This is a trick I've used before. Like, I know I'm going to end up with a hole like this. I'm going to throw that in there as construction at the right dimension, which was what? What did I just say? 150? No, is that the right hole? That the right hole. Which hole? That's... Which one? Which one was the right hole? I think it was the 129. I think it was the 129 was the... because these were the bigger holes. So we're going to throw this in at 129. But this is a trick. I know I need... That's like where my insert's going to go. So I can come in all the way out to here and know I have enough wall, right? That's all that trick is there for. Because it's I keep going back to the fact that I need enough room to get the wire between these two. But at the same time, the whole purpose of these guys is that they follow a line. And in order to do that, they also at the same time need to be as close together as I can possibly get them. As close together as I can possibly get them. And actually, I just flipped this guy over, and I really do need to... I'm going to unplug that battery before I short something out. Where's the power board? I keep squeezing something, and this is part of the reason why... part of the reason for the redesign. Like, this one's so beat up, something keeps shorting out as I move it. I can see LEDs turning on just as I'm moving the thing. But one thing I'm thinking, like... I mean, to follow a line, we kind of want these guys as close together as possible so the line can be thinner. And that's not this direction. Just straight up, if we think about this, the closest way they can be, go back to the assembly, the closest they could be is if, go back to the, the big assembly. Where's my big assembly? Where's my big... Oh, that is the big assembly. I'm just zoomed in. The closest they could be is if I would stack them on this edge. Right? That's going to put these two sensors even closer together. So I think I did all of that entirely 90 degrees around. Like, I think they should be mounted long ways. Then then I also don't have to worry about, like, cable to cable. I do need enough room to come out the back with a cable. Like, they can't be... they can't be directly up against this, right? I gotta have somewhere for the wire to go. But if I switch that around, and if I make this 0.8, and I make this the 0.5, right? That's gonna be the orientation that gives me that gets them close together. And then at that point, like, I can't, this is the whole pattern, so I can't, like, butt these up, but I can get pretty darn close. I like that, and then I can even, center them rather in this gap, center them. That gives me room for the cable, like cable coming in, cable daisy chaining, right? I dig it. I'm going to go with that. That means I have to, well, first I'm going to accept that sketch, leave it where it sits, and then I'm going to modify this sketch. It. I am going to let it touch the battery compartment. I like that sort of anchor point. We're going to call this 1.125. I'm just going to flip those dimensions the same way I did. What? Oh, it's because it's constrained here at the edge of on each side. I got to break them both. Break them both. And then basically this is effectively the board outline. I'm just going to move them in tight. And actually, I mean, we went bigger than the board. Can I do that? Like, can I do that? I guess I'll give it, I guess. So 0.8 here, 0.8 here, 1.6. I'm thinking 1.75, something like that, as a gap, just to make it 1.75 total. And actually, I don't even have to do that math, really, right? I can just dimension the whole thing. 1 point. Well, what does 625 get us? Like, I'll have to check. We'll have to check to see where the holes land. Like, as in, do I have enough material? I don't bump threaded inserts into each other. But I don't see why that wouldn't work. I just don't. So I'm going to go back to the old plan, the thing I did like way back. I need a point on the center of this line, which is going to be right there. And I'm just going to make that, grab the center here, make that coincident, and we're centered. Just that fast. Except that now. Okay, we're not tall enough for the plan that I had because these were in roughly the spot I wanted them. Roughly. Not exactly, but roughly. All right, easy way to fix that is to ignore the height altogether. Edit this sketch again. This 1.125, just ignore it. Get rid of it, and make this just even with this surface here. A piece of cake, right? Coincident there. Boom, boom. What don't you like? Oh, you didn't like that sketch? Why? Why? What happened? Which sketch don't we like? That's what I thought. Why don't you like that one? Edit. Delete. What's the problem with bringing this up here? I don't see why there should be a problem there. Except that sketch 23 is happy, but it didn't extrude it. Why didn't it extrude anything? That has to do probably with extrude settings. Let's merge scope. Edit. Why didn't it extrude? Oh. The parts either do not intersect or are not totally contained. Like, dude, what? Excuse me? Well, merge with all definitely didn't work. Because that's what it was at the first place. I get the impression that it's like only, it is, it's only, okay. Okay, it's only extruding those corners. That was the problem. We want to extrude that part. I mean, that helps. What if I turn that off? Merge with all. There we go. So now we got a good, I mean, it's not hurting us at all. We got a good platform there. These are the hole patterns. Now we just got to get basically, I mean, center it, right? So that sketch, edit. And actually, I'm going to do this same thing on two inner corners. And actually, I don't need to make them construction. We're just going to grab the points. I'm just going to set these equal. And I'm only doing this to make sure that I have clearance wall. I need some wall between the two inserts. That's really the only reason I am going through the hassle of adding those. They're just there for reference to make sure I have some wall. Go ahead and actually, can I do this and do this? And I want to make sure those, okay, they move. They don't move, but I can then dimension a wall. Like I want, that's a little excessive. 100 thou. 0.05. Whoops, 0.5. Thank you. 0.05. That's, I mean, that still feels like a mile when you really look at it, but I guess. And then we can just center this whole thing with a couple of lines. One here to the center of this line. Where are you? Where are you? I know you want to find it. There it is. There. You're going to be vertical. The same thing horizontally. That's not going to quite be centered, though. That's okay. Yeah. So if I do it here, because of the 45-degree angle, I'm losing that corner. It's not going to be centered from here to here, and I want as much as I can get on each side because I gotta run those wires somewhere. So best way to do a vertical centering. Suppose I have like a width mate, like, ooh, symmetric. What does that do? Oh, symmetric doesn't really work. Symmetric is not width. I kind of want a width, but I don't think I can do a width in, yeah, solid. That's not a, again, not a rag on Onshape. SolidWorks wouldn't be able to do that either. What I'm about to ask it to do. So best way to do this is I'm going to get rid of that line that I just created. I'm going to get these guys out of the way for just a second. I am going to draw a line from the middle of here to the middle of here. Right? That is going to serve as a way for me to go like this. And I'm actually going to drag them out of the way because I like to force, I like to visually see that it actually made itself horizontal. So horizontal, we're vertically locked, right? Now we got to horizontally lock. I can do that a couple of different ways. I'm thinking right now the quickest, since I'm, getting ready to be done with this stream for the evening, is to just do another line and make them equal. And we're centered. Like, we're centered vertically, we're centered horizontally, everybody's happy. We accept the sketch. I don't want to select the sketch, I just want to do the whole wizard. And for that insert, we needed a number 30 drill. 30. 200 thousandths deep. And flat. And now we can just select all 4 of these points. And that's going to get those sensors way closer together than they would have been if I had mounted them in the other orientation. And again, these boards, I mean, I could have recessed them, for that finished look. Well, now the question is going to be, the question is going to be about the wall if the boards are too close together. So I'm going to get the boards in my assembly where they need to go, which one? Which one? PCB component 2. The 53 here is this VL53 is the time of flight. This PCB component 2, which I didn't actually fix yet, so fix and group, as always, fix and group. Fix and group. And then I can bring those in. So let's insert those. And we want, whoops, that was generic parts, not insert. Current document, assemblies. And again, that was called PCB component 2. Is that really how it's going to come in? I guess it is. All right, let's do it. 1, and that is different than the one I brought in before. And PCB component 2, bring in another one. All right, and the same as always, accept and revolute mates on the whole pattern. So this whole top and bottom, like, I don't know, I'm sure it matters which one of these. If I want them to be absolutely as close together as possible, I'm sure direction matters. But frankly, they're symmetric. I can figure that out later. For now, let's just get it in there. Flip. Good. And then again, I like to do diagonal holes when I'm doing a mounting pattern, just for sanity, to make sure the whole pattern actually lines up good. Everybody, there's no red, everybody's happy. And I can tell you right now that I am probably going to want to space those out just a touch. So now that hole, trying to pay attention to which one I grabbed so I can at least orient them the same for now, becomes that hole. And then here and here. Okay, now my boards are very obviously encroaching on each other. That means I just didn't define enough wall thickness there, right? So get rid of that. Let's go back to the chassis and space mount. I want to make sure that I mean, the whole purpose is for things to fit together. If things don't fit together, we have a problem. So 50 thou was not enough. I'm going to go to 125 and just see, accept it. And because this is why I don't use the parallels, I mount based on the holes. As I move the holes, the board's going to move and I'm going to be able to see it after it refreshes. I've noticed it takes a bit, and I have not noticed a way to like force a refresh. That should be plenty. Like, that's perfect. I dig that. And actually in that orientation, those should be about as close as they're going to get together, right? These are, so even that orientation kind of works. Cool. Cool. I will also take a look, well, at this point next week, because I'm going to end the stream here in just a moment. Next week I'll take a look and make sure orientation-wise, and then, of course, getting the fasteners and all the inserts in. I was trying to get the parts on and mounted where they belong, but again, at the end, I want a complete bill of materials, so I need to make sure all of the threaded inserts are in all of these holes along with all of the screws, and that way, plus I need to order some screws. Like, I don't have a massive stock of very small metric screws just laying around. So while I'm here, I mean, because I'm, anal like that, I don't want to leave this part hanging out in space for a week. So we'll get it mounted. And again, I will have to verify. Basically, I need to verify which end of this is in from the Arduino and which one's out to the next board in the daisy chain. Because that's basically going to affect, which way's up or down. That's like the only thing that's going to affect which way is up or down. And if we look, cool part is, well, can't really see it from this angle, but if we look, this is completely below the screw boss, which is what we want, especially when we get onto these. Like, it'll just miss and shoot underneath it, which is going to be awesome. Like, that means it's as tight up as we can get it, right? So we're kind of cool. I like it. Go ahead and switch to the big screen again, and I'd like to thank you for tuning in here in the chat. I saw a couple of you wave your hands. Anyone watching in the future, hopefully this was helpful. As always, if you learned something, I promise it was accidental. But hopefully, again, the whole point of this is to sort of talk through the thought process, why I design things the way I do, or some of the thoughts that go through that you should kind of keep in the back of your head as you're designing things. So again, thanks for watching. We'll do this again next week, same time, same place. I look forward